Welcome everyone. I'm Mark Fox, CEO of NetEvents, and delighted to welcome the international press to this session today on data center technologies and trends. Chairing the session, we have Baron Fung, Research Director of Dell'Oro Group, and Baron is going to introduce his panel in a few seconds. Baron, over to you.
Thank you, Mark. Thanks for the introduction. I am Baron Fung. I'm the analyst at Dell'Oro Group, responsible for our data center research pertaining to cloud CapEx, servers, and server connectivity. It is my great pleasure today to be moderating this event with our distinguished panel of experts in data center technologies. Joining us today are Doug Gourlay, President and GM of Arista's Cloud Network Software Division, Jonathan Seckler, Senior Director at Infrastructure Solutions Group for servers and partners at Dell Technologies, Tony Bishop, Vice President of Platform and Growth Marketing at Digital Realty, and finally, Jacob Rapp, Director and Lead Technologist for Network and Security Office of CTO at VMware. Next, I'm going to go through some slides which will help set the stage for today's discussion. So just to start off, servers generally comprise of more than half of the data center capital expenditure and drives the forecast of assumptions for forecasts of other technology areas such as compute, storage, networking, power, and cooling. In this forecast here, we project server shipments to grow at a 6% CAGR through 2025. Growth is projected to be uneven across customer segments. Last year, the top 4 US cloud providers, Amazon, Google, Microsoft, Facebook, accounting for more than a third of the global shipments of servers worldwide, and will increase their share over time as they continue to consolidate infrastructure over time. We are expecting faster growth coming from the top Chinese cloud providers. Cloud adoption in China is still behind the rest of the world, so there are a lot of upside potential. Plus, the government in China is making a really strong concerted effort to boost infrastructure spending on the long term. The rest of the cloud segment, mostly related to tier 2, tier 3 cloud service providers, growth there could be mixed. We see this segment adopting a hybrid cloud strategy, and some of the larger cloud providers could potentially repatriate workload back from the public cloud to invest in their own infrastructure. While the telco currently occupies the smallest slice of this market, it is expected to be the fastest growing segment, driven mostly by new use cases that requires low latencies applications and would increase their demand for micro data centers with servers and networks at the telco edge. The enterprises are likely to adopt a multi-cloud deployment model with regulated or mission-critical workloads remaining on-premise. Recent events from the pandemic was really disruptive to the industry and drove some enterprises to adopt a more nimble and flexible IT approach. We expect the other, what we call the rest of enterprises, mostly SMBs, SME, to mostly migrate to public cloud as their preferred IT strategy. Next, I'll touch on some information about deployment of IT locations. In this slide, it is the same forecast data as the previous chart, but shows where infrastructure will be deployed. Today, most of the servers and infrastructure are deployed in centralized data centers, including point of presence in the networks, operated by the cloud hyperscale companies and large enterprises. Servers deployed at the infrastructure edge as multi-access edge compute nodes, or MEC, is still a small part of the data center footprint today. This is potentially a fast-growing market with triple-digit CAGR over the next 5 years. IT and networking vendors and ecosystem providers have been active in developing and evaluating solutions today. The edge could be a next driver in infrastructure spending in the long term. Then the question is, which set of customers will be investing and deploying these solutions? Will the telecom operators lead the way, or will the cloud service providers expand their reach to the network edge? We are also anticipating the high-end enterprises to deploy edge solutions over their own private networks. As we move to the next slide, I'll show how data center technologies are allocated in terms of CapEx. As I mentioned earlier, servers will continue to be a dominant spend in data centers, and their allocation of servers could rise relative to other areas given several drivers. One is the successive kind of server CPU refresh cycles, which would drive higher server content, increasing the adoption of accelerated computing, servers for AI and machine learning, and the continued use of servers to replace proprietary hardware and data center appliances through virtualization. Other components of the data center, from network infrastructure to physical infrastructure, would also need to evolve as well. All these factors would increase the size of this data center capex pie to nearly $300 billion by 2025. In the next slide, I'm going to talk about how the top 4 US is projected to invest in their capex this year. So we're expecting the top 4 US cloud to grow capex by 20% in aggregate in 2021. The spending here, as you see, can fall into 3 main buckets. Servers will be the primary capex driver, with server deployments to new data centers and servers used to replace aged expired servers. A combination of higher server content with more memory, more cores, and with Intel Ice Lake ramp could potentially drive commodity costs higher as well. For networks, the top 4 cloud will also undergo an upgrade to the next generation of networks based on 200 and 400 gigabit connectivity. And lastly, the cloud providers are continuing their expansion of data centers globally and will also drive the cost of physical infrastructure costs higher, as we can see in the next slide. This chart shows the total number of availability zones for the top 3 public cloud providers. The yellow bars is the cumulative total number of availability zones in 2021, and actually in 2020. And the green bars indicate the cumulative total number of zones over the next 2 years. These cloud providers are set to expand the footprint with their own data centers or through co-location providers. The total number of availability zones for each company could surpass over 100 in the next couple of years. It is really a race to see which provider has the most extensive network of data centers with the purpose of improving network performance, increasing redundancy, and increasing the number of data centers in different regions to meet data sovereignty requirements. In the next slide, I'll be talking about some of the accelerated computing trends. So we have seen a proliferation of specialized co-processors such as GPUs, FPGAs, and custom accelerators built by the hyperscalers, with growing demands in AI and ML related applications. I believe we're still in the really early stages of these transitions, and there's a lot more room for growth. But in order for the industry to adopt greater deployment of accelerated computing in both centralized and edge data centers, the industry really needs to come together and simultaneously innovate in areas of CPU design, system architecture related to memory, storage, and interconnects, heat dissipation, networking, and application development. In the next slide, I will talk about another type of acceleration related to SmartNICs. SmartNICs, also referred to as DPU, data processing units, are Ethernet adapters with an onboard programmable processor, such as an ARM chip or FPGA. Some of the major cloud service providers are fully deploying SmartNICs today. We could see in a few more years, the cloud and other cloud companies, enterprises, and edge data centers potentially deploying SmartNICs. We project as much as a quarter of the servers shipped in 2025 to be equipped with this kind of device. SmartNICs are designed to offload a wide range of services, such as networking, storage, and security protocols from the host processor, which could potentially help improve server utilization and reduce network latencies. SmartNICs also give control to end users and empower them to optimize their servers and networks through own software optimizations. This is my last slide. And next, we'll move to some of our discussion topics. So the first topic is pretty wide open, some of the current trends and advances of technologies in the data center. If we move to the next slide, we could. So before we kind of begin the sessions, I would like to take the opportunity for each of our presenters give a quick introduction of themselves. We can start on the left-hand side with Doug and move on to Jonathan.
Awesome. Thanks, Barry. Appreciate it. Doug Gourlay, VP GM for software at Arista. Get to look after a lot of our cool product lines, from network observability to how we're building WAN and edge routers, using some of the chipsets and systems we have available today, to cloud networking, normalizing connectivity abstraction in multi-cloud environments, to a lot of other fun ones. So yeah, it's been pretty awesome. Joined Arista in 2009, came back a couple of years, about almost 3 years ago, and also did a quick stint building the data center product division out when I was at Cisco for 12 years. It's a pleasure to be here.
Hey, yeah, this is Jonathan Seckler. I am from Dell Technologies. I work in the infrastructure solution group, marketing group. I lead the solution and server marketing organization for Dell Technologies, and been with Dell for about 10 years. And prior to that was at Advanced Micro Devices.
Excellent. Hi, folks. It's an honor to be here. My name is Tony Bishop. My background has been in distributed infrastructure, running data centers and IT for large institutions and multiple startups throughout my career. I'm part of a firm called Digital Realty, which is one of the best kept secrets in the world. It is the largest multi-tenant data center provider in the world, running in 6 continents, 24 countries, almost 300 data centers in 47 metros. We are where the cloud and the enterprise come together, and happy to share those insights today.
Hi, my name is Jacob Rapp, and I work for VMware. I've been here for about 6.5 years. I started trying to scale out the NSX business to where it's at today. And currently I'm working in the networking security office of the CTO on various new technologies and projects for the company.
All right, thanks a lot, gentlemen. So we'll begin our discussion. Like I said, this is a pretty wide open topic, current trends and advances in technologies for data center. And for today's discussion, let's begin with some of the recent trends on servers, given the wide range of platforms that we have really seen introduced recently. So let me start with Jonathan. So question is, Intel is ramping its production of Ice Lake servers this year. And obviously the cloud providers are looking to increase their spending significantly, mostly on servers as well this year. This new platform is packed with more cores, deeper memory, supports the latest interconnect standards. From your perspective, what are some of the immediate benefits some of these cloud providers can derive by adopting this new platform in terms of delivering better ROI, enabling new applications, et cetera?
Yeah, no, it's a great question, and it's an interesting phenomenon that I have seen this now over quite a few generations of server technology over the years, where the very famous quote of we're going to double CPU performance every 18 months is generally true, right? We have seen a real proliferation of additional cores, additional memory bandwidth, and other technologies related to that. I think, though, that the real benefit to the cloud providers, but the real benefit to the enterprises who are also investing in data centers, is the increase in automation capabilities that their platforms are going to be giving them as well. We recently here at Dell did a couple of studies. One was with Forrester. And one of the things they talked about was that one of the biggest benefits that enterprises who invest in their own infrastructure have found, surprisingly enough, is the benefit in increased automation. And that's really important over this past few years, because automation and the need for a lights out type data center, being able to work remotely is critical. And I don't think that's going to go away. The other thing that we found out with a separate research study with a different vendor, IDC, was that the criticality of investing in new infrastructure over time. We actually discovered that it is the total cost of ownership of a server that is a server infrastructure that's 3 years old, is actually less than keeping that same infrastructure around for 6 years. Meaning that as the benefits and performance that you get from these new architectures, the benefits and automation that you get from these architectures, et cetera, more than pay for themselves, over the course of a typical life cycle. And this becomes an important, factor as, new technologies like Ice Lake and the AMD EPYC platform are becoming to market, and et cetera.
Okay, so the point you make about benefits in reducing the life cycle, do you see that kind of translating to the enterprise customers as well? Because generally they keep their servers for a little longer while than
they do.
customers.
And I think they do because of what I would probably argue is probably a false economy, right? It is certainly easier to do that, and the amortization schedule on computer hardware is probably longer than the 3 years that I just mentioned. But yeah, absolutely. Enterprises will reap the benefit of a faster refresh cycle, mostly due to the improvements both in infrastructure costs, the reduced management cost, and the improved performance that they're getting over time. Yeah.
Okay, great.
Jonathan, well, I was going to say, Baron, one other thought on the Ice Lake transition is actually looking at some of the core technologies that Intel's embedded into a set of the Ice Lake processors. It actually creates conflict with one of your predictions, right? So the advances in SmartNIC, which is, obviously, like you said, predicated on the ability to offload some of the protocol handling to a SmartNIC or a DPU as a co-processing element. If I'm Intel, I hate that, right? Because it's like, hey, wait, I only get $500 or $600 per CPU, and you're telling me somebody's going to drop $1,000 on a SmartNIC and $1,500 on a badass FPGA or GPU or something. I'm frustrated when I see that. And if you look at some of the options within the Ice Lake family, they've introduced some of the switching logic they got from, I believe it was the Fulcrum acquisition, to having a multi-port switch in there with significant accelerators into crypto library handling, QAT performance, faster DPDK plane, and so on, as well as a pretty wide set of PCI interfaces, which does allow it to, obviously very quickly interconnect with some of the adjacent co-processing elements. But if I'm Intel, I'm going to do everything possible to try to shove into my Ice Lakes and the next generation of processor families targeted at the server reasonable enough acceleration to try to forestall the adoption of SmartNICs, because I want the money if I'm Intel, right? And I think that's a smart business decision on their part, is to create products that diminish the value of off-boarded GPUs and DPUs, and again, other accelerated co-processors. So it's kind of a co-opetition environment.
It is, but it's interesting, Doug. I'll pile on and say that it really then becomes an issue for the software community and ISVs, because they've got to develop to these different architectures. It'd be interesting. I don't know, Jake, if you have a point of view on this, but the whole benefit of SmartNICs seems like would go hand in hand with hosting the virtualization layer farther closer to the network.
Yeah, I mean, definitely. I think a while back we crossed the threshold of kind of the CPUs outpacing some of the network interfaces. I mean, the network interfaces are kind of going on the stair step, right, of like 1 gig to 10 gig, 10 to 40, 40 to 100, and so on. But the processors themselves, like even what's on there today without the SmartNICs, are more than enough to handle all the networking and security virtualization techniques that we're doing. I think if we look at SmartNICs, it gives us an opportunity kind of to extend that into different environments. So say you have these really high performance databases that you want to not run any type of agent on because you're very much focused on the performance of that platform. SmartNICs can kind of air gap out a virtualization tier that we can kind of develop on and distribute the networking and security functions directly there as well. I think there's other opportunities beyond just the standard compute to go with as well.
Yeah, that's a good point. Actually, I was planning to talk about SmartNICs in the next section on accelerated computing, but now that we're talking about it, maybe we can spend a couple more minutes on it. Yeah, Doug made a really good point about how processors and SmartNICs could be in conflict with each other. In fact, I mean, obviously a lot of the vendors that are not producing CPUs, network vendors or chip vendors, have some kind of a smart product in the portfolio. And of course, there's also the counterpoint in which processors, like CPUs, are getting more cores. So maybe the core processor is getting more numerous. So the benefit to offload the cores become potentially less beneficial with the SmartNIC. So this is something we're kind of paying close attention to see how that evolves. And regarding SmartNICs, do you see potentially it be able to offload some of the network functions, because there's some vendor solutions with SmartNICs that could take some of the automation from the network to the NIC itself? So what do you think about that? Maybe from Doug or Jacob, any comment there?
I mean, I'll just start it with, I think the race is effectively between a SmartNIC vendor, a GPU vendor, whatever the dedicated co-processing vendor is, to build something that is more differentiated and significantly faster, or more feature capability or whatever. Let's just say it has more business and technical value than that which is delivered in my stock processor. As long as they continue to keep a reasonably wide gap there, and they're delivering things that customers perceive of high value, there's a market. Now, the market, as the CPU continues to add more capability in it and so on, they're going to always try to take the 80th percentile, right, and down, and maybe more if they do a great job. But there's a gap, and it's like, hey, I'm a hyperscale guy, I might need this. I mean, even back in the late 90s, we saw web front ends being built with SSL coprocessors because the crypto library processing was significantly more required in a big web scale company. And then fast forward 3 years and it's built into a load balancer. Fast forward 5 years, you have decent crypto lib support in the CPUs, and the SSL co-processing market just completely disappeared over a 5-year horizon. So I think there's always an opportunity, and it's incumbent upon the co-processing vendor to try to stay ahead of the curve of what can be done in a sort of system on chip design, coming out of Intel or coming out of one of Ampere or one of the ARM library of companies as well, which, I mean, when you look at it, delivers probably an order of magnitude more actual processors to the market than Intel does. And we've certainly seen the beginning of inroads, both in Amazon and now just announced this week in OCI and other cloud providers, of the ARM architectures being offered as well, which is another thing to just be aware of and pay attention to, because the per thread execution performance at lower power draw is significantly advantaged on those risk-based architectures. And kind of back to Jonathan's earliest point on, hey, if I want to have a highly efficient data center, it's all about power, right? And it's how much power I can shove into an environment, how much I can cool it, and therefore the most compute I can get out of it as possible. Efficiency is the game in a lot of these large providers. And I think ARM has an advantage for certain workload types there. And given the broad ecosystem of development driven out of the mobile and IoT worlds, and now with an obvious move into the compute area, I mean, it's something to also pay attention to. It's happening.
Yep. Yeah. Now that you touched on ARM, just wondering from an ecosystem perspective, what needs to be done to come together to see more ARM adoption from the server vendors, networking, software, and so on? We've seen some obviously nice traction, right, coming from AWS. Ampere has made some significant announcements recently, so I'd like to see what the play is for that.
Yeah, I'll seed with one thought for you, Baron, which is the thing that Apple developed that allowed the real-time emulation and translation of Endian-dependent x86 architecture code to be executed on top of the M1 processor. If there was a really reliable open source project of that, and hint to Simon and Drew and all my buddies at ARM, that would be pretty valuable, because people like me who might have an Endian-dependent operating system with a lot of user space code would probably get a kick out of it and might be able to find some value there.
Right, good point. Okay.
Baron,
I'm sure there's others.
Hey, right. Baron, I think for the audience, I've been really enjoyed this geek out, and I'm sure the audience has too. Maybe if we've been talking about the what, but maybe if we kind of pull it to the why also. What I would pose for us all is you hear the driving of it, driving intelligence down, conversion, density, et cetera, and the awesomeness that you just heard from the esteemed panel. we kind of pull it back to the why, I think to answer your current trends, what's driving this? And what I would pose to all of us think about is, let's understand the impact of digital technology, social, mobile, analytics, cloud things to business processes across all companies. That's what's driving it. And what I would put is, we see that as a place where Arista, Dell, all the wonderful folks that you see on the VMware technologies, et cetera, happening with enterprises and service providers. It's really what I would pose the data creation lifecycle. And the data creation lifecycle is now changing where it originates. Creation's happening at the edge, right? It's happening in many different places by users, sensors, and things. The processing, just to give you kind of stats, we did a study called Data Gravity Index, because we start to see a lot of customers changing how they build out their infrastructure in a more data-centric way. And here's a couple of interesting stats that makes all that geek out very relevant. Number one is on the data creation rate, currently in enterprises G2000, just the Forbes Global 2000 enterprises alone, they're creating data at over 600,000 gigabits per second today in 2021, going to more than 1.5 million gigabits per second in 2024. That's just data creation. Then let's get to where Doug and the team are heading on the processing of why you need DPUs or you need converged systems, why you need intelligent networking with it, is because the processing alone is about 23 exaflops just in the G2000 today, moving to 30 some exaflops in 2024, just to process what's being created. Then when you look at aggregation, here's the outstanding one that people have to also understand is over 178 terabits per second of data that's being stored in the Forbes Global 2000 enterprises per second. And then that's growing to over 621 terabits per second 2024. So I pose that and interject this just to kind of level set the why, right? There's an explosion of where data gets created, needs to be processed, enables intelligent workflows, and all this awesome technology you just heard has to get placed. And that's why what I saw, Baron, in your slides for the audience is you're talking about, hey, it's about to go through another whole wave of growth in processing, more intelligent processors, and you're going to see the hyperscalers and the large enterprises really driving that. So sorry to interrupt, Doug, but I just think that the relevant of the why to go with the what kind of ties to this topic. I hope that helps, Baron.
Yeah, that really helps, Tony. And yeah, just touching on your topic, I mean, in one of the slides, we saw the hyperscale companies really racing to the top to build more data centers. And we're seeing the kind of the enterprises doing the same, especially some of the, I think, the big financial institutions are kind of returning to growth this year. I think seeking co-location providers like yourself as partners. So just wondering how this, kind of build out, it relates to the data gravity index.
Yeah, so
not just in terms of volume of data collected, but how is distributed regionally.
It's a great proxy for, what we see is why we see the shift to a data-centric world. You hear AI, you hear intelligent workflows, right? You hear the ability to unlock insight. That's why you need all this special processing and all these technologies, and why you need to network together from core to edge. Think of it like a proxy of demand, right, for this specialized supply. And that proxy of demand is driven by population, right? It's driven by connected devices. It's driven by this data creation rate. And then you just start to map that globally. What we're seeing is the largest provider of hyperscaler capacity, like i.e. we build the data centers or a lot of them for the hyperscalers, and we also provide the capacity for the large enterprises. And when you see that kind of that demand supply, those two big demand entity types coming together, what you're starting to see is you're seeing accelerating growth rates, but you're also seeing accelerating growth rates that's more, let's call it fit for purpose. We see another wave of, and I'm sure all the intelligent geeks on the call here with me would say high performance computing is going through its next wave, probably like the third generation of it. Why? Because you have physics limitations. So when you think of the demand of data centers, it's shifting from, yes, the hyperscalers and some of the biggest will build their own, but they're moving to third-party multi-tenant data center providers that can do hyperscale to traditional retail colo. And you're seeing them where, look at this industry, it's an accelerated growth rate. It's going to, how do I solve this globally? And Baron, I think that's where it gets really exciting, because it's like kind of like the hidden infrastructure place where it all meets. And what I would say to you is that the numbers that you're projecting may actually be conservative, and that in the audience, as a media, it's an area to track where data centers can be a proxy for how fast digital transformation is occurring and how data is getting utilized. Food for thought.
Tony,
Great,
Tony, do you also see a change in the requirements for these data centers? You know, especially when it comes to moving data closer, or you know, the processing closer to where the data is created?
Excellent. Yes, we see both, Jonathan. What you see is you see the cores. If you go to the hyperscale core, traditional, where their compute model and storage is, that's continuing to accelerate, right? They can't build it fast enough, and they're pushing. They're pushing. How do I drive horizontal scale in a more intelligent way faster, and then leverage technologies like you all provide to be able to say, how can I automate it? You know, how can I provision it, etc. So that's continuing to happen. But what we're also seeing is we're seeing the densification of systems in non-public cloud environments, let's say cloud adjacent, sitting between, let's call it the middle, between the edge, whatever that religious definition is, and the core, right, of legacy and next gen, is you see data aggregation of public-private data sets, you see analytics, and you see AI turning on. And what ends up happening, Jonathan, is that we're seeing this DPU, GPU, like the hot conversation you just had, starting to drive up density within a cabinet, starting to really run very hot. So you need containment, you need structured cabling. I don't know if anybody's ever looked at the back of these cabinets, but when you look at the back of these cabinets, the amount of cables coming out of these specialized processors, GPUs, etc., the structured cabling that's needed is changing. Why? Because then when you start getting into mathematical calculations, if you don't have synchronous calcs occurring, your math gets off, your model doesn't learn, your AI is useless. So that's what I see, Jonathan, you know, with our
Yeah,
customers.
no, we're seeing the same thing. I like to say that there's at the end of the day, you know, whether your data center is for a medium enterprise or, you know, Amazon, it's electricity goes in, mathematics comes out, and then the byproduct is heat. And you know, the real value, I think, for our customers, all of our mutual customers, is how good are we at reducing the heat and eliminating it so that you can get more mathematics. And I think that's spot on, and doing it in different places these days as well.
Yeah, so if you think about like the challenge that developers and enterprise have with all of these systems, I kind of listening to the conversation, it's like there's lots of different environments to think about now.
Yep.
We had been
Yep.
primarily focused a lot on bringing the public cloud experience back to the on-prem environments or the private clouds, but now it's not enough, right? We have to think about multi-cloud. And okay, how developers want to develop anywhere, and wherever the data is, they want to put compute power, whether it's an edge or public cloud or even out to the branch locations. So it creates a scenario where you need to think about unifying operations. And that's where I spend a lot of time from a networking and security standpoint. Since we've abstracted everything into, or virtualized everything into kind of the processing power of the server, the networking and security functions, that becomes even deeper and deeper as we go along. Like we started out with just networking, but now we're kind of moving into the advanced security functions such as IDS and IPS and load balancing, and even some of the network detection and response capabilities that we can distribute everywhere and unify across lots of different environments, because really the operational aspects become really difficult to maintain as these environments continue to kind of grow in just various different locations.
Yeah, just to add on top of that, you know, with a lot of these solutions that are more kind of services oriented. I mean, there's been kind of a growing trend in which a lot of the vendors are delivering kind of servers or IT as a service, right, in terms of a consumption-based model. So a lot of the enterprises can help them conserve CapEx, right, which is crucial nowadays. So obviously Dell has, you know, introduced the Apex recently. You know, just wondering how that appeals to the enterprise customers from that perspective, and if Doug and Jacob can talk about, you know, how these kind of services could interoperate with multi-cloud environments, that would be helpful as well.
Yeah, the way to think about it, you go back to the why, to Tony's why is if you're a business, if you're an organization, and your business is data, or is your business is digital, you need some kind of infrastructure. You need to invest in that infrastructure. But again, if you're a business, the accounting model, it much prefers a pay-as-you-go kind of model, right? And so the ability to be able to deliver the exact amount of predictable, whether it's compute performance or it's networking or it's storage, et cetera, on demand, I think is critical. I think it's fundamentally that is the appeal of the public cloud. And yet there's going to be times when enterprises need that infrastructure closer to hand, under closer control, in order to pull that innovation out of the system. And so that's really where we see the value of Apex as Dell, and I'm sure our competitors have similar situations too. And it's really important that those things happen. I really appreciate that you've got Tony on the line as well, because we're also seeing that growth in these data centers, in co-location providers, pushing these facilities closer to where data is created at the edge, et cetera.
Jonathan, the only thing I don't want to say that there's a set of, I've seen two wildly different approaches to consumption. Now in this extremely elastic environment where it's like, I have to plan for, Black Friday in a retail environment. And,
right.
I think the ability to get the on-demand resources without the CapEx spend is one of the leading drivers of cloud consumption, not to mention just the inherent agility associated with the cloud environment. Versus, hey, I have to wait for my vendor to ship me servers. It's a huge win. On the flip side, though, you've got, by the way, server, storage, network, not picking on anybody, although we all have supply chain constraints in the current market. The one thing I've noticed is slightly different is it depends on the source of capital for the company. There's, Tony and I have a shared background working together at some banks in the past. And when your cost of capital is that of a global financial institution, sometimes it's a lot easier for them to buy and capitalize as opposed to pay recurring OpEx costs. And so I'd say it's just a function of your cost of capital and your source of capital. But yeah, I mean, the general non-financial services enterprise, I think you're spot on getting to, and this is a conversation we have with most of the procurement teams. They certainly want to see as much determinism in the pricing models as possible, which does sometimes belie the cloud first message.
Yep.
Right. Like, hey, I want to go cloud first. Oh, wait, I didn't expect it to, my developers used it a lot faster than I expected. And who's the idiot who left, 100 VMs running for 3 days, and
that happens. Yep.
M3 XLs or something. And it's like, oh, that hurt. So yeah, getting the controls aspect is something that a lot of companies don't take into account when adopting a cloud first message. And they learn the hard way that consumption controls, procurement controls, and some of the things that they've developed really strong operating models for on the enterprise side, both from acquisitions to whether it's ITIL or whatever on the day-to-day operations, are still very relevant in some of these cloud environments.
Yeah. It's great to hear that vendors have a wide range of innovative solutions to fit different type customers. Some providing them with sort of a cloud-like experience, like on-premise, which is really important nowadays to give enterprises extra flexibility. So let's move on to the next topic. Shifting gears a bit on the second discussion topic is related to the proliferation of accelerated computing. I touched upon this in some of my earlier slides, particularly with coprocessors. So it's like GPU, FPGAs, custom ASICs that are designed for more specialized workloads, and how that could become more efficient than just using general purpose CPUs. But the point is, you cannot really just put in more of these accelerated servers in the data center without really addressing the whole ecosystem, right? From compute, storage, networks, and also enabling developers with the application frameworks to kind of produce valid use cases and so on. So just want to take a few moments for each of you gentlemen to talk about some of the potential bottlenecks, right, or architectural changes that are needed before we see wider adoption of accelerated computing. And first of all, assuming that the demand for AI applications continues to be really strong as well. So any thoughts there on addressing system or ecosystem bottlenecks?
I'll just throw a seed kickoff out there for sport, and this might be one that's designed to get Jonathan and Tony to just pile on and either argue with me, which might just be fun for the entire audience. Who knows? But I mean, let's throw a rock and see what happens, right? I used to joke that the entire AI movement was actually built off the back of crypto mining, right? As everybody's like, hey, let's do more crypto mining. Let's build, and you literally saw Antminer ASICs rolling off the leading edge of the node off of TSMC, driving the latest in tight geometries coming out of there. So you then watched a lot of GPUs get consumed, and then applications get developed that utilize those. So I think there's always a pull push there, in finding that unique application that generates enough volumes to get the chipsets made that provide these accelerations. And I think you've correctly identified, whether it's GPUs or AI specific processing, or FPGAs for a little more accelerated but general purpose, or these DPU environments, whether it's a smart NIC or whatnot that offload some of the processing from the core. There's applications and use cases for all of those today. And like we said earlier, it's a race between the creation of value in the accelerated piece and the system on chip or the core CPU being able to absorb enough of that function for it to be practical, cost effective, and efficient in execution. And that's the ongoing race. The other last thing I'll throw is a lot of this is always, in my mind, being a networking company, been somewhat networking centric. I've always felt that every time the network advanced in capability, whether it's the next order of magnitude speed performance, the next 50% reduction in latency, the next evolution, the ability to have guaranteed or reliable or self-correcting transport, every time that's happened, you've taken one of these peripherals and you've extracted it from being bound to the CPU. And again, a good example, if you look at the Grace processor architecture coming out from ARM interconnected with the NVIDIA GPUs using the NVLink 4 technology, you're seeing an example of a coherent transport being used to allow for the intelligent decoupling of these outside of the sheet metal of the server. And I've kind of personally always envisioned that there's this day we get to where I have racks of memory, racks of CPU, racks of storage, racks of DPUs, racks of crypto accelerator, whatever it is, and I have a capable network architecture, fabric, transport, whatever term you want to throw at it, that interconnects these, which allows for the dynamic assembly of resources necessary to process a given set of workloads at that time, and then most importantly, the releasing of those when they're done executing so they can be repurposed and reconsumed by others. Whether this is literally GPUs being interconnected over IP, I don't know. But I've kind of always envisioned that's the natural progression we're on as CPUs get faster, accelerators happen, and networks become eminently more capable generation by generation.
When I was in the 1990s, we used to argue in my compact back in the good old days, so to speak, when which constraint would we alleviate first, bandwidth or storage? Who would have guessed that today the answer is, who would have guessed that power and distance are the real constraints, right?
Yeah, I mean, physics sucks, man.
Yeah, exactly. and I think you're calling it in a lot of ways. We'll get to the future of technology in a moment, I think, as we discuss this. But the advancements and the innovations around things like Gen Z Consortium and these other alternative interconnects going beyond PCI Express are critical to enabling, like I said, a lot of this accelerated computing, because the physics of power and the physics of distance just don't lend itself to keeping everything in this monolithic device. And And so I see that being a big deal. I think the other interesting part of this is we as an industry talk about the killer application, like what's the application that's going to drive this? And the irony, I think, is it's the hardware drives the applications in so many ways. The software development model has to follow what the architecture delivers to them. You can't write AI code for GPUs until there's a GPU in a device and being sold. And now we're in this really interesting world where there is so much choice and so much innovation that ISVs they should be, should be the best, should be the funnest time in the world for them. They can develop anything for anything.
Yeah, I think yeah, I mean, as these constraints we saw even back in as big data was first coming about, right? We needed to move the processing power to where the data is, because we're not going to move it. We're seeing that kind of same thing. Maybe I'll take it like a different view at it than just the applications, AI and ML into like the infrastructure. So we look at the same thing when we just move towards like an NDR solution that's distributed. Before, we used to have to kind of put on these taps on the wire and try to pull data off the wire back centrally to do security and controls. But now we've kind of taken that same notion and said, okay, can we do this on the server in line to when the packets are going through in a distributed way? So I think that's kind of what I see from an AI and an ML perspective, is that it also gives us far greater opportunities. So instead of having just these services at the trust boundaries, we can do it everywhere. So as we implemented our NDR solution within the actual east-west traffic in the data center, we can get to almost a 90% better false positive ratio, because we see everything. We can look at every single hop along the way, not just the trust boundaries, where you start to kind of just look at aggregate data instead of actual packet by packet flows. So I think it unlocks a lot of interesting opportunities from the security world as well.
So Jacob, do you see like kind of a SmartNICs sort of like an enabler for these accelerated computing, because they have the ability to kind of look at the packets, do some automation, network, and so on.
Yeah, I think it helps. It makes things better, right? I mean, we can do it today without, but I think it unlocks other opportunities. So what I think mentioned before is that, okay, so we say we virtualized in a virtualized environment, but how do we extend that into, like, say, a high performant database system that maybe wasn't virtualized? And we had kind of moved down the path of agents at first, but then that shares the same memory space of this high performance database, and maybe it's built on a custom operating system that just doesn't really support it. So we can air gap it out into a SmartNIC and have that same distributed functionality to those bare metal high performance systems as well. But then if you take that one step further, and this was interesting with 4 8 cores, but as we're at 64 cores now, it becomes an interesting kind of management and cost takeout of, like, well, yes, we are taking up some CPU power from those cores to do networking and these security functions. So on a large scale, this one server now looks like a data center of the past. So can we start thinking about costs as well as we move forward?
Sure. And of course, with accelerated computing, there's obviously a lot of implications in terms of the mechanical, thermal aspects of it. So from Tony's perspective, what kind of solutions in terms of form factor, rack architecture, or innovative cooling solutions like immersion or liquid cooling, are these some of the kind of solutions you're considering implemented into your future data center builds?
Yeah, I think that's a good transition, Baron. If you pull it back of, causation, we really kind of go, hey, the technology continues to innovate, right? It's moving to more composable. If I recap kind of what I'm hearing from Doug and Jacob and team, it's more dynamic, right? Can be assembled, reassembled. Those environments then still tie back to what services, what applications, what use cases, which is what, Doug kind of started the brilliant, kind of evolution of this last dialogue of accelerated computing. And when you think of it, accelerated computing is early innings. And that early innings is because, If you don't have all your data in the right place, or you don't have all the applications exchanging with that data, you don't have it networked right, you don't have your, your securities and controls like Jacob just said, you kind of come back down to that data center is, what you do in the physical data center almost becomes a second thought, and it needs to become part of the first thought as you're kind of architecting. And what we're seeing is that we're seeing that when you start running, whether it's short or wide, right, analysis, and you start running that on a more constant, continuous basis, that's where you're seeing the scale up again. It's almost like, remember the old scale up, scale out, right, team? You're kind of like seeing that scale up again. And in that scale up, it's translating to physical attributes of hyperconvergence and density of power, cooling, space, along with then what you're putting into the modular kits and boxes and switches and so on. And you'll see that with each of the vendors that you've talked to here. What we're doing is we're already dealing with the fact that you have the same schizophrenia as you cut across organizations, that there's inconsistent standards and approaches. So how do you got to be able to accommodate those different ones. So it's a very fit for purpose world, even in the physical, right, bridge to the digital. And so immersion, right, containment, you've got different containment strategies to extrapolate heat as close as possible to where the heat's being created from this infrastructure. As I talked about earlier, you have cabling, Baron, that is as important, cable management. People, it's a hidden thing that's as important as the cooling, along with the power distribution. And then how you time that power distribution, not just to the rack or to the pod, but how you time that power distribution that is sustainable, right? That is available. And you're dealing with power disruptions in the grid. You're dealing with alternative energy sources coming into the buildings, right? It's a whole picture architecture, which is what I think you heard Doug talk about and the others that you got to be thinking about, right? So from the business to the infrastructure, right down into the data center. And then the only other part I'd say, Baron, is what you've heard today is the data center of the future is shifting to being much more, right, distributed. It's going to be much more decentralized, where you're going to have smaller versions of it or tailored versions based on the volume densities of workloads and data flows. And I think you got to think about it from a physical and virtual security sense, because I think that's what Jacob was hitting on earlier, is it's a zero trust world, right? You got to have securities and controls at ingress, egress. You got to have it physically. You got to have it virtually. So I think that's how to think of it, Baron, and that's how for the audience to think, is that you got to be looking at, boy, this is a very codependent business architecture, technology architecture to physical deployment architecture, and all of it has to link together.
Right. Yeah, this is a great segue to our last topic, which is basically what the future of data centers look like. So Tony touched upon about, and actually we touched upon this topic earlier, about how data centers are kind of becoming, more and more decentralized. Enterprise data centers, I think, will continue to stay. They likely adopt a hybrid multi-cloud strategy going forward. So just wondering, as these data centers become more centralized, what's the implication for cloud enterprises, companies, in terms of, what changes are needed from an infrastructure and networking standpoint?
Sure.
We can start with, go ahead, please. Yeah.
Yeah.
Go ahead. You go.
All right. I was going to pile on what Tony was saying beforehand about kind of the whole world is already changed a bit this past year from kind of the perimeters dissolving, right? From the data center in general, with the whole everyone working from home and so on, right? It's interesting. As I talked to various different security teams, like they actually thought it was easier when there was a hard perimeter, right? Even though it may have been less secure, who knows? But it was easier. Their job was easier because they're like, oh, I have this hard perimeter, and that's what I deal with on a day in and day out basis. But now that the perimeter has dissolved, it hasn't gone away. It's just turned into hundreds of micro perimeters. Whether it's your user connecting to a SaaS application, your users connecting to an application of public cloud data center, or connecting to private cloud data centers, and so on. So there's obviously definitely a new edge. I think Baron, you showed in one of those slides of like this new edge compute that's popping up, and that's the whole, I think, secure access services edge market that kind of is saying, okay, well, if there's no perimeter, how do we combine some of these micro perimeters into maybe a POP-based location? So we can start serving not just the security functions and networking functions to interconnect everything, but also, and we start thinking about pushing that compute out to the edge as well, from those architectures. So yeah, I mean, data center of the future is not just one location, it's many locations. And I think we have to get the operations right to make this successful. Because as much as I know, Doug, you talked about the different racks of maybe processors, or in a rack of storage, and a rack of whatever, if it's not in a way that's operationally feasible, then for enterprises probably won't adopt it in the private world as much, I think.
Jake, I was comically, I'm glad I pointed, because I was going to say almost the same thing, which is the location stops being relevant, right? But the location of your data, storage, compute, networking, whatever, can only stop being relevant inversely if you're centralizing something, which is control. If the business doesn't feel they're in control of their data applications and what's running where, and they don't feel they have visibility into it, that they can trust it, to Tony and your point on zero trust architectures, shout out to John Kindervag on creating that ages ago. What you find is, if I can't trust it, I won't let it go.
Yep.
But if I can trust it, then location becomes less relevant, and I'm capable of putting compute, storage, whatever, where I need it to be to most effectively support my end users. And over the last year, we have seen a shift in end user population. The whole zero trust thing, big fan of it, and the idea of creating micro perimeters around the protect surface of an asset and shifting it to as close to the asset as possible greatly reduces the blast radius impact of change. And the thing I like about networking is I generally have configuration is fairly, for most devices, somewhat immutable. I mean, I make a change, then I can run on it for hopefully weeks or months without having to make another change too quickly. Whereas in the world of load balancers and firewall devices and security policy and controls implementations, you find a much more mutable, highly dynamic, rapidly changing set of controls based on changes in threat model, changes in user location. So the deperimeterization and creating these micro or pico perimeters, whatever you want to call them, are as close to the asset as possible, allows for me to adjust those policies quickly and not have the risk associated with screwing something up and blocking my entire data center from accessing its DNS server, or putting 100 gigs of traffic down a 1 gig link, or any of the numerous examples we've all lived through of galactically, cosmically stupid outages caused by human error.
Yeah. Isn't that, Doug, on that, like you talk about, I think Arista talks about like a cognitive network. And I think, yes, if I build off of that for the audience, right, just to kind of, again, bring this back, is the data center in the future is both logical and physical. It's decentralized, right, and everywhere. But you have, if it's like a data center becomes centers of data, if I kind of recap Doug in a different way, the network, right, needs to be intelligent. You need VMware types to be composable. You need Apex type delivery of the kit as a service. And you got different instances tailored where, kind of that data creation. But it goes back to why I'm pushing all of us and pushing the audience, that the digitization of processes, whether it's the business process or what you're hearing a lot of us talking about is the infrastructure process, just to enable that business process. That's where people, the perspective I think gets lost, is because they think of it on a point only, not on a, hey, end-to-end workflows and processes of business and infrastructure now have to be decentralized and be ubiquitous, yet have to be intelligent on an end-to-end basis. Would you, Doug, say that's kind of a fair statement? Jacob, does that kind of tie back to what you're both saying?
Yeah, I mean, I think you bring up an interesting point too. It's like, it's not just, it has to be end-to-end, and this is what we're seeing. I mean, we talked about data center, but technology a lot, but it's also a people and process function as well. We have a lot of those conversations with many organizations around, okay, well, how do you, especially with end user kind of being in a silo from app, and app being in a silo from others, right? So I mean, you have to start breaking down some of these silos to start to push forward with some of these architectures as well.
Yep.
it's a good reminder that it's really all about the people. The process is there to enable the people, the hardware, the software. We're all there to enable the people who are doing the innovating in these data centers. I would say that my top three, like, where's the data center of the future? I think step one, it is autonomous. It manages itself, because we really don't want people spending time on the rote work of keeping things running. I think that there's a really nuanced conversation that comes out of the distributed idea, which is that, when we talk about edge, it's not a place in the network. The edge really is the edge of IT, right? It's the edge of where people go, to make innovation happen. And in order to do this, and in order to manage the risk and all these other things, you have this I think this transition of away from the idea of being safe, and more toward the idea of being agile, right? And the people, like, in order to live in this zero trust environment, in order to maintain the quality of the innovation that they're doing, they're going to have to focus. IT has to focus on being agile, as opposed to keeping the trains running on time.
And Jonathan, kind of riffing off something you and Tony, Tony with the word cognitive, you with automation. I think one of the lessons we've learned is the amount of data, to your point of exabytes of data getting created earlier, Tony, the speed at which it's moved, the speed at which things are processed. We are currently beyond a human's ability to operate, troubleshoot. It's like, good luck. Hey, I'm going to look at, a billion packets per second of sniffer traces and figure out what's happening. Yeah, right.
Yeah.
Right. So it's time for us to build the machines and train the machines to look at the models we wanted our network implemented on, and then ensure adherence to the model, using that to identify discrepancies and identify positive behaviors as well. I mean, I hate to go down, look, AI and ML is going to solve everything, but there's proven use cases of supervised learning models for automatically selecting which runbooks were likely to correct a particular set of issues that I have experienced in a networking or full stack computing environment. And I'm not saying that it's perfect every time, but gosh, even 80 to 90% accuracy on selecting, we see this collection of events, it might be this root cause, and here's a run book you used the last 27 times that fixed it, gives that new operator a heck of a lot more confidence in making that adjustment or change to keep the environment running, while also targeting them at the real problem, as opposed to letting them sit there and chase noise and chase their own tails for days. So I think this concept of systems level observability, network level observability, feeding into how do I monitor and manage, learn from the environment I'm operating, to then make relevant changes to keep that environment as operational as possible, is another key area of continued innovation and investment.
Yeah, I totally see the same thing from a security world too, where you're shifting from like chasing bad to how do I keep a yes a yes?
Yeah.
Right, and that's the model where I see a lot of, especially in zero trust as well. It's like it's not about trying to kind of block people. It's like I want to enable them to connect and keep them connected as long as possible.
Yeah, there was an interesting research paper done out of MIT that it analyzed all of the controls positions to keep a nuclear reactor performing the way you want it to. And it said what you actually need to monitor is, when did the controls go out of the positions that are known to be good and work? And you could actually apply a lot of that controls theory back to, say, network and distributed and compute systems, and say, here's what good looks like. We should really only start worrying when we start seeing things, controls positioned, being moved outside of this good. That's where we need to investigate and apply deep learning or ML models, or, again, forward-looking observability into it.
So there you go, Baron. Now that's a soundbite. Augmenting, right? It's, if you kind of distill it back, augmenting decisions and actions, right? And making it, instead of chasing bad, chasing good, enabling new. I mean, this is all good geek stuff, right? Sound
right. We'll keep that in mind for sure.
Uh-huh.
So anyway, we're at the top of the hour. So
down.
should we move on to wrap things up? So just maybe right now, just each of you take a quick moment to give the audience some key takeaways. That would be really helpful.
Who do you want to go first?
So we start with Doug, and then followed by
You know, can we go alphabetical next time, please? So not I guess we're alphabetical by company. There is a method to the madness. I'll tell you just one quick funny story. There was a name change that Arista went through in 2008, and one of the key criteria of naming was it was required to start with an A, so we'd be listed alphabetically ahead of our competitors. So it was a very thoughtful, intentional A. So I guess, conclusion, I mean, I think we covered a broad swath of things. Ranging from, today still the primary limiters of data centers, scale, performance, execution, and so on seem to be more physics bound in many cases than technology bound on capacity. I think we covered a really good area on the limiting factor in addition to physics is going to be the human capacity to operate and manage at scale, which we see continuous innovation in observability, machine learning, and systems managing systems as opposed to people managing packets or things like that. I think that's going to be a key evolution that allows us to move to this deperimeterization of the network as we increase the centralization of the control to enable the decentralization of the asset, which gives the enterprise operators the comfort necessary to be confident that data and applications can be processed remotely and wherever they need to be to offer the best end user operator experience without compromising the integrity of the enterprise or integrity of the environment. I think that's one of the big ones. Comically, the whole network evolves, things deconstruct was like, I think I wrote a paper on that in 2005, and it still seems to be happening. So cool. I'm sure we'll reach a point where it stops happening, or the thing that has to happen becomes back to physics limited, and the distance of a 1 meter cable is a problem. We will get there. And when that happens, you'll see this interesting shift as long as processors continue to evolve to more things being shoved into system on chip designs, because that's as close to the actual processing as you can get. We've always seen that with level 1, level 2 caches. We're now beginning to see it, like we said, with the Ice Lake processors with network function enhancements in the form of crypto library support, quat, and things like that being driven further into the CPU itself. And then, like you said, the AI ML evolution is driving one of the primary accelerator implementations in the form of GPU adoption and dedicated co-processing adoption for that, as well as we see smart NICs and DPUs starting to appear. But I think there is going to be a constant push-pull between the CPU manufacturers and that, especially as we see the ARM processors continue to take off, because a lot of those are designed with some of those SOC designs that implement those functions natively, like we saw in the Annapurna Labs implementation at Amazon.
And, Jonathan?
Yeah, so I'm going to double down on the people idea. I think that Pat Gelsinger this year said that sometimes it can take 10 years to move a week, and sometimes it seems like in a week we can advance a decade. And we just have come out of one of the biggest changes in our collective industries that we'll probably ever see. And within a week, IT stood up and delivered in ways that all across organizations that we would never have thought possible. And it's a huge kudos to IT out there. And the future of the data center really is tied back to what these organizations are looking for. I believe that they're going to pivot from the reaction to this past year toward innovation and transformational activities. They need a platform and an environment that they can innovate on, an innovation engine, if you will. And like I said, I think that it'll be one that is focused on making their making their lives easier through autonomous operations, but also being able to deliver on the this idea of enabling them to be agile and create innovations regardless of where the data is, but also regardless of what multi-cloud choice model that they've built.
Great.
I'll turn.
Thank you, Jonathan. Yeah. Yep. If I kind of build off of that, so if I sum it in takeaways for everyone, we talked about the why, being a perfect data storm, right? We talked about and shared that it's really data centers to centers of data that are more decentralized and more ubiquitous. It's because the physical and digital divide, right, needs to converge. And that's because of physics. I would throw in compliance and regulations are also going in globalization that I would tie with it. And then we talked about that the innovation and capabilities of all these new accelerated technologies are going to unlock when you think of it on an end-to-end basis. And remember, our quotable soundbite, augmenting decisions and actions to chase the good instead of chasing the bad. That's what I'd leave you with. Jacob.
Jacob.
So from my side, I think ultimately we had kind of been focusing a lot on the public cloud experience on private cloud, and now we're moving to a ubiquitous multi-cloud experience, which includes edge and everything in between. And what I'm really excited about is this has unlocked a lot of great technologies that we can do more in a distributed fashion in software, right? Like whether it's the processor capabilities or smart NICs or anything in between. We're moving up the stack, right? Especially from a networking and security standpoint. Like we started kind of down packet by packet, looking at how do we recreate networking from a virtualized world. And now we're all the way up into sidecars and Kubernetes land, right? As we think about service meshes and API calls. So like we're networking and security is kind of distributed now in a way that we can start kind of thinking about higher level technologies and security initiatives. So for me, it's like, it's like keeping the yes a yes. Like whether it's I want to get applications in production faster, wherever they may be, or I want to enable users to connect to those applications and keep connected on any device, anywhere, any location.
Right.
So for me, it's like, definitely about those applications.
Yeah, thanks, panelists, for a very lively discussion, debate. Hopefully the audience, took a lot of valuable information out of this. And also thanks to the audience for attending. Thanks NetEvents for organizing this great event.
Yeah, thanks so much for bringing us together. I appreciate it.